Hi, hello, vanakkam, and welcome back to yet another episode on Little's Law YouTube channel. And today we are on our day two of upskilling our performance testing, our performance engineering skills. And in our previous video, we saw the seven activities of the basics of performance testing. So today, out of all those seven, I'm going to discuss about the first activity, which is the identification of the test environment. And this is very critical because everything that which is every action that we do sits on top of the test environment. So the first part which we see here is the test environment, because this test environment which we are talking about now serves as the backdrop for conducting the performance test, and it comprises of various elements. It includes hardware, the software, the network configuration, alongside any specialized tools which are necessary for executing these tests. For example, it can be neoload, it can be JMeter, it can be load runner, it can be anything, whatever you name, any performance testing tool. So combining all these, the hardware, the software, the network configurations, and the performance testing tools to execute this test. So the primary objective of establishing a test environment is to simulate a real world condition as closely as possible to assess the performance characteristics of an application or the system accurately. So that is our first priority, and that's what we are going to work towards. So that's going to be our objective. So it's going to establish a test environment. So the key principle for designing the ideal test environment, what is the key principle? So in an ideal scenario where the goal is to evaluate the performance of an application in a production setting, and for that the test environment should replicate the production environment. This means we have to ensure that the hardware specifications, the software configurations, the network architecture has to closely match those of the actual production environment. So as I have told you, the hardware configuration, the software specification or the configuration, and the network architecture should match the actual production environment. I think uh, I'm discussing this in every video of mine and in to any of our subscribers, that it has to match the production environment. The test environment should match the production environment. So on top of this, the load generation tools are introduced to simulate the user interactions and generate realistic workloads, while resource monitoring tools, we know there are like a lot of monitoring tools, resource monitoring tools like Dynatrace, Datadog, AppDynamics. So those tools help track and analyze the system behavior under varying loads, because we do the test with different workloads. So these resource monitoring tools help us by tracking and analyzing the system behavior under varying loads. So I think so far you could have understand what are we trying to say or what are we going to do when identifying the test environment. So now we will see the overcoming of overcoming the challenges in the test environment. So, however, creating exact replication of production environment for testing purpose is often challenging, and it's quite impractical due to various constraints, because it involves some of the constraints like the cost, because replicating the production environment for a simple testing, that too for a performance testing, it involves a lot of cost, it involves a lot of manpower, a lot of work, and a lot of scalability has to be done, and also resource availability, as I told you. So there should be resources available, and it involves cost and the scalability. So therefore, while striving for similarity, that is production, the pre-production, so the testing should be similar like production. So it's essential to understand that the test environment may not always perfectly mirror the production setup, and that is the major challenge in the test environment replication. So now we will see the next part. So before that, we have to understand the common and the most dominating challenge, which is replicating the production to the test environment. So now we will see the building and configuring of test environment. So it involves several steps. So out of which the very first part is the hardware configuration. So understanding the specifications of servers, the processors, the memory and storage devices used in both the test and production environments. And it is essential to ensure that the hardware resources allocated for testing adequately represent the expected usage patterns and workload demands. And moving on to the second part in building and configuring test environment is the software stack. So examining the software components, including the operating systems, the databases, the web servers, and middleware deployed in the test environment. So any differences in software versions or configurations between the test and production environments must be noted and accounted for testing or during the testing. The third part when it comes to building and configuring is the network infrastructure. So analyzing the network topology, their bandwidth limitations, latency, and connectivity parameters to replicate the communication patterns observed in real world scenarios. And this is very important because since we are replicating the every part of real world scenario, we have to analyze the network topology, the bandwidth limitation, their latency, and the connectivity parameters. So load balancers, firewalls, routers, and DNS configurations should be configured to mimic the production condition accurately. And this is very important because in every part of our testing, we are very concerned about mimicking the production environment. And then moving on to the fourth part, which is tooling. So selecting and configuring appropriate tools for load generation, performance monitoring, and analysis based on the specific requirements of the application or system under test. So, understanding the capabilities and limitations of these tools is essential for designing effective test scenarios and interpreting the test results accurately. And moving on to the fifth part, which is the data management, which we call as test data management. So, identifying the type and volume of data required for testing, which includes realistic data sets that reflect the diversity and complexity of user interactions. Data seeding, database configurations, and data management strategies play a crucial role in ensuring the test realism. So we have to since we are replicating the production environment, it does not stop until there. It does involve in ensuring a real test by doing all these data part, that is data seeding, database configuration, and data management strategies. And moving on to the last part in it, which is collaboration and communication. So establishing effective communication channels with the stakeholders, and this is very important because we have to have communication with the stakeholders, which includes developers, system admin, network engineers, and business representatives to gather requirements and to address the concerns which we face and should coordinate for all the testing activities seamlessly. So, by mastering all these fundamentals of test environment identification and configuration, performance testers can conduct comprehensive and meaningful performance evaluations that provides valuable insights into the scalability, the reliability, and responsiveness of the systems we assess. And moving on to the next part, so here we will understand the similarities and the differences between the test and production environment, which is crucial for effective performance testing. So we will see a little deeper into it. So the first part is the hardware. So when it comes to the configurations, we have to compare the hardware configurations. So what are the parts that we have to compare? So we have to compare the CPU, the RAM, the disk space, and other peripheral devices between the test and the production environments. And we have to ensure that the resources allocated for testing accurately represent the production setup. And when it comes to the machine hardware, so we have to pay attention to specific hardware components like the processor models, the memory capacity, and disk types to ensure compatibility and performance consistency. And moving on to the second part, which is the network. So, the network architecture and the end user location are very critical because we have to analyze the network topology. So what type of topology or what type of network topology do they use or what has been implemented? which includes the routers, the switches, and the network segments to mimic the production network setup. So in fact, all these part will be same because anyways, both the production and the test environment will be running from the client location or from the client setup. But still, it's always good to analyze these part, the routers, the switches, and network segments, and by considering the geographic location of end users to replicate diverse network conditions. So in case if your users are in different geography, so you have to consider that as well. So you have to consider the geographic location of the end users to replicate the diverse network conditions in this scenario of cloud, where we have our load generators or where we have our web and app servers in different geographic locations. So we have to have an eye on it. And then the load balancing implications, where we have to understand how load balancers distribute the traffic across servers in the production environment and configure similar load balancing strategies in the test environment to simulate realistic traffic patterns. And then at the end of the network, we have the cluster and DNS, the domain name system configuration. So we have to configure the clusters and domain name system settings to mirror the production environment accurately, which we have to ensure for seamless communication and name resolution. And then the third part, which is the tools, which is the very necessary part when it comes to performance test execution. So the load generator tool limitations are of high priority because we have to evaluate the capabilities and constraints of load generation tools to determine their suitability for simulating realistic user behavior and workload scenarios. And when it comes to the environmental impact of monitoring tools, we have to assess the performance overhead which is imposed by the monitoring tools on the test environment to minimize the interference with the application under test. So that's why it's very important to check or do an impact of monitoring tools. And then when it comes to the software, so other software installed or running in shared or virtual environments, and we have to identify for any additional software components or services running concurrently with the application under test to understand the potential resource contention issues. And when it comes to the software license constraints or differences, we have to ensure for any compliance with software licensing agreements and verify any discrepancies between the test and production system. And when it comes to the storage capacity and seed data volume, we have to estimate the storage requirements for test data and seed data volumes to replicate the production data scenarios accurately. And then the logging levels. So we have to configure the logging settings to match the production levels, capturing sufficient data for performance analysis without overwhelming system resources. For example, sometimes if we reduce the or if we reduce the timing between collecting the log, so what happens is like there will be like more amount of log that will be get collected, which is not necessary in case when we are running a big test or a huge test or for a soak test. So in that scenario, the system resources might be used and we might be running out of our space or the look or the size of the data. So it's always better to configure these logging settings to match the production levels so that while we capture the data, we will not be overwhelming our system resources. And then the external factor. So we have discussed all the parts, which is the hardware, the network, the tools, the software. But apart from these, we have the external factors. So what are the external factors? So volume and type of additional traffic on the network. So consider the impact of background traffic, such as external API calls or user interactions on the application's performance. That is an external factor. And scheduled or batch processes or updates or backups. So these account for scheduled maintenance activities, the database backups, and software updates that may affect the system performance during testing. So we have to keep an eye on all these external factors and we have to note down whether there are any impact while running our testing. And when it comes to interacting with the other systems, we have to identify the dependencies and the interactions with external systems or third party services to simulate realistic integration scenarios and assess overall system performance accurately. So, by examining these critical factors and ensuring alignment between the test and production environments, performance testers can conduct rigorous and insightful performance evaluations that reflect the real world usage scenarios. And moving on to the last part, which is where we find or where we see the critical considerations for test environment. So these are for the test environment setup. So these the following part which we're going to discuss are the critical considerations when it comes to the test environment setup. So the first part of it is the access to servers and software. So many of us would feel the pain of getting access to servers and software. So while performance testers typically focus on testing activities rather than installation and administration, having access to servers and software or collaborating closely with administrators who manage them can be invaluable. And this access enables testers to troubleshoot issues effectively, gather necessary data, and ensure that the environment, which is the test environment, aligns with production configurations. So next, when it comes to the data seeding, so we have to identify the amount and type of data required for testing, which is crucial for emulating real world conditions accurately. And testers should determine the necessary data sets to simulate various usage scenarios and ensure that the test environment is seeded appropriately to reflect typical production data volumes and characteristics. And when it comes to identifying critical system components, it is very essential to identify critical system components and assess whether any of them have known performance concerns. And this is very critical because we have to know that there are any performance concerns, and on top of this we have to understand for any integration points with external systems or third party services, which is vital. And testers, the performance testers, should document these components and integration points to prioritize testing efforts and address potential bottlenecks effectively. And when it comes to engage with the IT staff, so we have to build a collaborative relationship with the IT staff, which is very essential for successful performance testing. And testers often require support from IT professionals to monitor the network traffic, to configure the load generation tools, and simulate realistic test scenarios. And establishing open communication channels facilitates coordination and ensures that testing activities align with organizational objectives. And when it comes to the load balancer configuration, so load balancers, we all know it plays a very crucial role in distributing the incoming traffic across multiple servers to optimize the performance and reliability that they mirror production settings accurately. So testers should verify the configurations of the load balancers in the test environment, and also you have to make sure that they exactly mirror the production settings. So this includes validating the load balancing algorithms, session persistence settings, and health monitoring configurations. And when it comes to the DNS validation, so the name resolution with DNS can significantly impact application performance, particularly when establishing database connections or accessing external resources. And testers should validate DNS resolution in test environment to identify for any potential latency issues to ensure seamless communication between system components. And when it comes to the validation of network components, the performance testers, we should verify that the network components such as the firewalls, the routers, and the DNS servers treat the generated load similarly to real world production scenarios. And this validation helps ensure that the network configurations do not introduce unexpected bottlenecks or restrictions that could skew the test results. And that's very important when it comes to the test results, right? So moving on to the resource monitoring and diagnostic tools. So we have to leverage resource monitoring software, diagnostic tools like the profiling tools or whatever the tools which are available for doing the monitoring, and for any utilities in the test environment, which provides valuable insights into the system behavior and performance metrics. And the system administrators can assist in setting up and configuring these tools to capture relevant data and to identify performance anomalies and troubleshoot issues effectively during testing. So overall, By considering all these key points when characterizing the test environment, the performance testers can establish a robust foundation for conducting comprehensive and meaningful performance evaluations, which ultimately ensure the reliability, scalability, and responsiveness of the system under test. So, we have come to the end, and overall, we have discussed about identifying the test environment, and I think I have covered almost every part of it, starting from the software to the hardware to the tools, network, load balancers, whatnot. I have to come covered every single part of it. So please do watch the entire video. This will definitely help you to improve your performance testing skills, your performance engineering skills, and if you are preparing for your interview, this video will definitely help you to crack your interview, because I have covered almost all the key areas and the key points and the pain areas in the performance testing. So we'll meet on day 3 tomorrow. So until I meet you in another interesting video, it's bye bye from Astin Shanmugam and Little Slaw.